4.6 Nonlinear systems. Our objectives are solve systems of equations in two variables that contain at least one second-degree equation. A nonlinear system of equations is a system in which at least one of these equations is not linear, meaning it is not a line. You have been studying one class of nonlinear equations, the conic sections. No solution is when the two nonlinear equations do not intersect. One solution is when the equations or the two intersect in one place. Two solutions is where they would intersect in two places. Three solutions is where they would intersect in three places. And four solutions is where your conics would intersect in four places. The solution set of a system of equations is the set of points that make all of the equations in the system true, or where their graphs intersect. For systems of nonlinear equations, you must be aware of the number of possible solutions. Looking at the first example, it says identify all the solutions for each system. So when we look at the two parabolas that are graphed on the first graph, we see that they intersect here and they intersect there. Those are the only 2 points of intersection, which are our solutions. So we have a solution at 2, negative 1, and we also have a solution at the ordered pair 6, 1. If we plug these ordered pairs into the given equations for those quadratics, it would satisfy both equations. When we look at the next example of a quadratic and a line, we can see that they intersect at one location. More specifically, that location is 1, negative 5. So there is one solution that makes both of these systems true. The next thing that we see is a line and a quadratic, and this line will never ever intersect this quadratic function, so we say there is no solution. When we solve systems of equations algebraically, we use substitution, equal value method, and elimination. So when we have 4y equals x squared plus 8x minus 16, and our second equation is x plus 2y equals negative 8, the first thing that comes to mind for me is I want to use substitution. I know I can subtract this 2y, and I now know what x equals, negative 2y minus 8. I can take what x equals and plug it in for all of the x's in my top equation. So I have 4y is equal to the quantity of negative 2y minus 8 squared plus 8 times negative 2y minus 8 minus 16. I want to distribute out my negative 2y minus 8 times negative 2y minus 8. Negative 2y times negative 2y gives me a positive 4y squared. Negative 2y times negative 8 gives me a positive 16y. Negative 8 times negative 2y gives me a positive 16y. Negative 8 times negative 8 is a positive 64. I distribute my 8 to the next parentheses. 8 times negative 2 is negative 16y. 8 times negative 8 is negative 64. Minus 16. I need to combine my like terms. Negative 64 and positive 64 cancel out. 16y and negative 16y cancel out. So I have 4y squared plus 16y minus 16. I need to move my 4y by subtracting it. So I have 0 is equal to 4y squared plus 12y minus 16. I now need to, we have a quadratic, so to solve a quadratic you can use completing the square, factoring, or the quadratic formula. The GCF between all of these is a 4, so I get 0 is equal to y squared plus 3y minus 4. This is factorable. 4 and 1, I want my 4 to be positive, my 1 to be negative. When I use the zero product property, set y minus 1 equal to 0, I know y equals positive 1. Y plus 4 equals 0, I know y equals negative 4. So we've now found two y's, so we need to plug those y's back in separately to solve for the x to figure out the ordered pair of where these intersect. So the easiest equation to plug this into is x equals negative 2. We now know y is negative 4. Negative 2 times negative 4 is positive 8, minus 8 is 0. So when x equals 0, y equals negative 4 is one of our solutions. When we plug 1 in, x is equal to negative 2 times 1 minus 8. Negative 2 minus 8 gives us negative 10. When x is equal to negative 10, y is equal to 1. Let's take a look at the system to the right. We have y squared minus 2x plus 8y minus 6. We also have y squared plus 2x plus 16y plus 70 equals 0. My first inclination was to multiply by a negative 1 and try to cancel out my y's. However, it won't cancel out our linear y. So my next thing is, hey, my x's are already the same coefficient with opposite signs. Let's use elimination. Add these two together, get rid of our x's, and then solve for y. So y squared plus y squared gives us 2y squareds. Our x's cancel out. 8 plus 16 gives us 24y. Negative 6 plus 70 gives us positive 64 is equal to 0. I now know these are all divisible by 2, so I'm going to factor out that GCF. I'm left with y squared plus 12y plus 32 equals 0. I now know that this is factorable. 4 times 8 is 32. If their both signs are positive, they add to equal 12. Y plus 4 equals 0. Y plus 8 equals 0. I know y is equal to negative 4. Y is equal to negative 8. I now need to plug those back in. So negative 4 squared minus 2x plus 8 times negative 4 minus 6. Negative 4 squared is 16 minus 2x minus 24 minus 6 equals 0. 32. When I combine my like terms, 16 minus 2x minus 38 equals 0. 38 and 16 and negative 38 gives me a negative 22. Negative 2x minus 22. Add 22. Divide by negative 2. X is negative 11, so we have an ordered pair at negative 11, comma negative 4. And when we plug our negative 8 back in, negative 8 squared minus 2x plus 8 times negative 8 minus 6. Negative 8 squared gives us 64 minus 2x minus 64 minus 6 equals 0. 64 and negative 64 cancel out. Negative 2x minus 6 equals 0. Add your 6. Divide by negative 2. And x is equal to negative 3. So our other point of intersection for these two parabolas is -3, -8.